All right. Colored pens up, pencils go down on your desk. So number one, what did we get? Got 1, 2, 3, 4, 5, 6, 7, 8, 9 confident people, 10 confident people. We'll start with Alex, Laurel, and then Catalina. What'd you get?
X is less than 9.
Okay.
X is less than
So you agree with him?
X is less than 9.
We all think it's X is less than 9, and that is correct. X is less than 9. What about number 2? What did we get? We'll start with Yadesh, Michael, and then Adriana. What'd you get?
X is less than 5.
All three of you agree that X is less than 5. Mark your answers correct or incorrect. Write down the correct answer if you got anything wrong. Now I open up the floor for any questions you may have on anything you see here. Amir, yes. Well, did you get number 2 correct?
No.
Okay. So the first thing you're going to do is see if your teammates have them correct. So hold on a second. I'll do that for you. So give me a thumbs up if you got both questions correct. Thumbs up if you got both questions. Okay, put your thumbs down. So now you know you have teammates who can help you out. Borrow one of their papers, follow along their steps, look at your steps, and find your mistake. I'm sorry, for those of you who misunderstood, I wasn't really just talking to Amir, even though he was the only brave one to ask. I was talking to anyone who may have made a mistake. Any other questions about what's going on here? Okay, so let's hit the pause button. You can see from the title that's been across the screen since the beginning that today we are going to be studying compound inequalities. So before we begin, let's review the progression again. We started out the year with one-step equations. One-step equations, one-step equations. Then we went to two-step equations, multi-step equations with variables on both sides. Then we went to absolute value equations. So we progressed from simple equations to very complicated ones. Then we reset in chapter 2. We started with inequalities. And we started with simple inequalities, progressed to two-step and multi-step, and then multi-step with variables on both sides, which we just confirmed that most of you understood from today's warm-up, and now we are to more complex. But compound inequalities has nothing to compare to in the world of equations. Compound inequalities are very unique. And so you do have all the skills that you need to be successful with this idea, but you've never seen it before. So in some sense, this is not new, and in some other senses, this is very new. So you're going to see as we work through this. The beginning, we are going to lay some foundation, meaning you have to establish some understanding of what a compound inequality is, and then we're going to work with them. A compound inequality is basically two inequalities connected together. Two inequalities connected together. There's two ways to connect them. We can connect them with the word and, or we can connect them with the word or. So we're going to study what an and looks like, then we're going to study what an or looks like, and then we're going to put it all together. So this is an example of an and inequality. This is what it is like written out in English. All real numbers that are greater than 0 and less than or equal to 4. So a compound inequality is really two inequalities. So where in this sentence are the two inequalities? Let me show you. Greater than 0. That's one inequality. And less than or equal to 4. That's the second inequality. And they are connected with the word and. All real numbers is English for a variable. All real numbers means x or n. So here's what it translates to in the world of algebra. And this is what I meant by you're seeing something very new. This is one example of a compound inequality. And so you can see that it has two inequality symbols. So where are the two inequalities? So let me show you what I mean by this. Well, there's one inequality. And there's the other inequality. Now put them together. There's one inequality. There's the other. Put them together. You have a compound inequality. Let me teach you how to read this. In English, we start reading from left to right, but in algebra, that's not always the case. In this, we read from the middle. We read from the x. And this is read, x is greater than 0 and less than or equal to 4. So we are actually reading x is greater than 0 and x is less than or equal to 4. So we're actually reading them and connecting them with the word and. Does anyone have any questions about that? So we have it in English, we have it in algebra. What about the graph? Well, can you graph that? I would say that I would expect every single one of my students should be able to graph that. Could you graph that? I would expect every single one of my students to be able to graph that. So if you can graph each one individually, then you can graph them all together. So we have a 0 and a 4, which means we need both of them on the number line. If we have one inequality, we have one circle. If we have a compound inequality, we will have two circles. So we need 0 on here. So there's 0, 1, 2, 3, 4, 5, 6, and that'll be -2. Now we need the two circles. It's easy to tell where the circles go. The circles go on top of the numbers. So we're going to have a circle on the 0 and a circle on the 4. Let's start with the 0. Put a circle on the 0, but now we need to figure out is whether or not we're going to fill it in. Do we fill that in or do we leave it open? Someone chime in. Jesse, what do you think?
Open,
Why?
because it doesn't have the line underneath.
Yeah, there's no bar underneath here, which means this is an open circle. Very good. Now we're going to put a circle on the 4, and we need to determine whether we're going to fill it in. What do you think? Kaylee? Yeah, it's going to be closed because we have a bar underneath right here. Now we need to shade. Where will we shade? What do you think? Got a few people think they have an idea? 4 people? Tristan?
I think you say the 0 all the way, put a different color.
Okay. Michael? Okay. What do you think, Alex? Yeah. Look at where the X is. It's, what could we say? It's what? In between, right? The X is in between the 0 and the 4, so we shade in between the 0 and the 4. So an AND inequality gets shaded in between. The OR is going to look a little bit different. We'll get to that in a moment. So any comments or questions so far before we continue on? Go ahead.
Like you said, not to write it like that, the X has to be on the other side.
That's if you have just a single inequality. So what he's asking is, Mr. Gallup said if you get this as your answer, that you're not supposed to write it like that. You're supposed to rewrite it by flipping the whole thing around so that it's like this. That is still true. But that's for a single inequality. A compound inequality is different. This is something new. So now you need rules for this as well. The rules for this still apply, and there's rules for this. That's all. Any comments or questions about that? All right. Don't worry, we're going to see this a lot. Any other comments, questions? All right, here is a compound inequality connected with the word OR. All real numbers that are less than -1 or greater than 2. So there are 2 inequalities built into this. Less than -1, greater than 2, and it's connected with the word OR. Here's what it looks like in algebra. An OR inequality is easier than an AND in some sense because it's really just 2 inequalities connected with a word. So while this one, the AND, gets written in a new way, the OR is just this inequality right there, that inequality right there, connected by the word OR. Any questions about that? So let's take a look at and see how this is graphed. Again, we need both numbers on the number line somewhere, so I need a -1. I'll put it over here. So that would be 0, 1, 2, 3, 4, 5, -2, -3. And now I'm going to need my 2 circles. One circle is going to go on the -1. One circle is going to go on the 2. You can tell what type of circle based on the symbol that's with it. This does not have a bar underneath, so like Jesse explained earlier, that's going to remain open. This does not have a bar underneath, so this is also going to remain open. Bless you. Now we need to shade.
Thank you.
Where do you think we're going to shade? Garen, what do you think?
To the right of the 2 and the left of the -1.
Very good instinct. That is exactly what we are going to do. I call it opposite ends. We are going to shade everything down here because that's what that says. X is less than -1. That's all the numbers less than -1. This says X is greater than 2. Here's all the numbers greater than 2. And then, of course, you put an arrow on the end to indicate that it goes on forever and ever. That is not optional. There must be an arrow on the end. And so what this means is any point on the line that's shaded will be a solution to this. So if I pick this point right here, -3, and I plug it in, it will be true. If I pick the 6, plug it in, it will be true. If I pick a point from in here, it will not make this true. That's what the graph tells us. Anyone have any comments or questions on how we got from English to algebra to the graph?
On the test, do we have to, can we do what you did, like not have the number but write the tick mark in between?
Yeah, absolutely. As long as you clearly have labeled your intervals,
Okay.
I can tell that this is going by ones. Even though I didn't write a 2 there, that must be the 2 because it's between 1 and 3. Absolutely. Good question. All right, so now we're going to work together, going from English to algebra to a graph. So, you do not need to copy everything. In fact, for today, you can just write example 1A. You don't have to write the instructions. You don't have to write part A, but you need to read both of them carefully. So the first thing we need to do is figure out if this is an and or an or. And it's not necessarily super easy, so read carefully. What do you think? Is this an and or an or? What do you think, Amari? Okay, Laurel? You think it's an and? Yasmin? Are you sure? How do you know? Yeah, but there's a word or also. Okay, but it's one of them, so you have to know how to read it. Okay, back to Jesse. You sure? How are you sure?
Because when it says greater than or equal to, that means the sign greater than or equal to.
Yeah, I love the way you just explained that. This word or is actually part of this phrase right here. That all goes together. That's a symbol. This word and is what's connecting the two inequalities. And that was a great explanation. I also did something else. Anyone notice the word and? Adriana? I put it in italics, so that was a little clue. The textbook and tests and quizzes won't have that. That's just to help us get started. Okay, but Jesse's explanation is really the important one. So we know this is an and inequality, which means the x goes in the middle. So go ahead and start with your x. The arrows always point this way, and you'll understand why in a moment. But we just need to figure out which ones need the bar underneath and which ones don't. So it says all numbers, that's this, greater than or equal to. So that's this symbol right here represents this right here. So that gets a bar. And then it says greater than or equal to -5, so -5. And less than, no bar, -2. Yes, Tristan? Well, let's flip it around for a second and see what happens. Let's flip the entire thing. You don't have to copy this, just watch up here. What's wrong with the one I wrote in green? Looks totally fine to me, but there is something wrong with it. Yasmin? Okay. So it doesn't follow the order of the words. But what if I switch the words around? What if I wrote all real numbers that are less than -2 and greater than or equal to -5? What if I took this and switched it with that? So then you're saying I would have to write it this way? But something else wrong with it. And it's something very simple. Amir?
Because it's saying less than.
Okay, well this says less than negative 2. X is less than negative 2. That's what it says. This says x is greater than or equal to negative 5. It says the same thing, but there's something wrong with this. Chanel? Yeah, let's take a look at the graph and then we can see. So now we're going to graph it. That's part of what we're doing. So everyone needs a graph. And now we need a negative 5 and a negative 2. So negative 5 is over here. Negative 4, negative 3, negative 2, negative 1, 0, 1. Anyone see what's wrong with the one in green now? All right, maybe you'll see it when we finish the graph. I'm going to put a circle on the negative 5. That has a bar underneath it, so we need to fill that in. We're going to put a circle on the negative 2. That's going to remain open because there's no bar. And where are we going to shade? Where are we going to shade? In between or opposite ends? Where do we shade? In between or opposite ends? Just 3 people have an idea? I'm not doing a very good job, I guess. Okay, Chopin? Adriana, what do you think? Yeah, it's going to be in between because this is an and the x is in between. So now someone tell me what's wrong with the one in green. Still don't see anything wrong with it? You don't see anything wrong with this? You don't see anything wrong with this? Cheyenne?
It doesn't make any sense
It doesn't make any sense. Why?
because the 5 is less than -2.
5.
Well, yeah, negative 5.
Negative 5. Yeah, the negative 5 is less than negative 2, but yet I have the negative 2 on the left here. It makes no sense. So it's not really wrong, but it just doesn't make any sense. So we don't write it this way. This is not accepted. We write it this way. Don't worry, you'll get used to it. I told you it was something simple. The smaller number always needs to go on the left. Smaller number on the left, because all the smaller numbers are on the left. Any comments, questions? Good. Let's translate an or. So I already gave it away that this is an or inequality. There's a couple of word ors in here, but as Jesse explained, greater than or equal to actually goes together. This or is the one that's connecting them. Since we have an or inequality, we're just going to write the word or, and then we're going to write an inequality on the left and an inequality on the right. And this time we're going to have 2 x's. We're going to have an x and an x. Start with the first one. All real numbers that are greater than or equal to. Greater than or equal to. 3. 3. Or less than negative 3. So we've translated. Anyone see anything wrong with it? I did what Yasmin said earlier. I followed the words in order and I wrote it down. Anyone see anything wrong with it? Kaylee? They're not pointing the same way. This one's pointing to the right, this one's pointing to the left. You mean that they're pointing to the middle? Okay. Good. So, Tristan?
Because I think or is supposed to be going outside and is supposed to be going in between. And because like the greater than
Mhm. Yeah, absolutely. But think about what I just said up here. What did I say about this number? Where is it supposed to be?
Oh, the negative is going to be,
Yeah, the smaller number is supposed to be on the left, and look, I have the smaller number on the right. So you have to actually think about this. Remember, algebra is about the details. And so this and this need to switch places. This needs to come over here. This needs to go over here. And now it's written properly because now the smaller number is on the left. You'll also see it on the graph, which is exactly what Tristan was just talking about. Watch what happens when we graph, and then you'll realize even more why it only makes sense to do it this way. Now I need a -3 and a +3. Let's see if I can fit that in. -3, -2, -1, 0, 1, 2, 3. So we need a circle, an open circle on the -3 because of that. A closed circle on the +3. And now where do we shade? Do we shade in between or do we shade opposite ends? In between or opposite ends? Where do we shade? Go ahead, Yasmin. Now we shade the opposite ends. And now the way we wrote it here matches the way it's graphed. And it makes much more sense now. Because look at what would happen if I had it the original way. If I had this over here and this over here, does that really match? Because the -3 is here, but the 3 is here, and it just doesn't match. So we really want it to be like this. Any comments or questions? Any comments or questions? All right, so we just laid the foundation. Now we're going to build on it. We're going to introduce ideas from the past and put it all together. So, now, solving. Solve a compound inequality. That's an and inequality. So everyone write example 2, solve, and graph the solution. I'm going to rewrite it just so I have a little more space and a little more room. You don't have to write it twice. Just write it once. So this is new. But I did say several times already that you already had the skills you needed to be successful. So now watch. Don't write anything. Don't erase anything. Just watch. And think, what if I changed it to this, and I asked you to solve that? What would be the first step? Don't put your hand up. Give me a thumbs up if you know the first step to solving this. Okay, a bunch of you. Good. Good. Isabella, what's the first step? Well, if we add by -7, unfortunately that won't do anything good for us. Yeah, we're going to add 7 to both sides. Give me a thumbs up if you agree with that we add 7 to both sides. Only some of us agree. Michael, you disagree? Well, what do you think it should be? Add 27 to both sides? But remember, we're trying to isolate the variables, so adding 27 to both sides will bring more information to the same side. It won't eliminate information. So she was right. We want to add 7 to both sides. Okay? Well, what if I change it, and what if I said... solve that? Give me a thumbs up if you know the first step to solving that. Okay. Amani, what's the first step in solving this? Add 7 to both sides. Give me a thumbs up if you agree with Amani that we're going to add 7 to both sides. Okay, so put your thumbs down. So if it's this, we add 7 to both sides. And if it's this, we add 7 to both sides. What do you think we're going to do? We got a bunch of light bulbs. 1, 2, 3, 4, 5, 6, 7, 8 light bulbs. 9 light bulbs. All right, Michael. Say it just a little bit louder. Wow, you actually stole my next statement. That was amazing what you just did. Because we always say add 7 to both sides, right? But now how many sides are there? There are now 3. So now instead of saying add 7 to both sides, you say add 7 to all sides. Add 7, add 7, add 7. Yes, you have to write it 3 times. Absolutely. Draw your elementary school line, and we still work down just like we've been taught since the beginning. This will cancel out, and so the middle becomes 5x. The symbols don't change because we did not multiply or divide by a negative number, did we? So the symbols stay the same. Now, just computation. Negative 27 and 7 is negative 20. 18 and 7 is 25. Any comments, questions about that? So now we are here. What do you think we're going to do to continue? Oh, we got more light bulbs now. Chanel, what do you think? Wow, I love the way you said that. Divide all sides by 5. Because she knew that we needed to get rid of the 5, so we divide by 5, divide by 5, and divide by 5. Yes, you have to write it 3 times because that's how you demonstrate you know what's going on. This cancels out, and now we have our x in the middle, which is what we wanted. The symbols stay the same because we have not multiplied or divided by a negative number. Negative 20 divided by 5 is negative 4. 25 divided by 5 is 5. The smaller number's on the left. Now we can circle or box up our answer and be happy that we solved it correctly. Does anyone have any comments or questions about how we did that? What do you think? Okay, we'll find out. Any questions? Tristan?
I thought you said not. I thought you said not to switch the arrows. If we divide it by a negative number.
What's the rule for inequalities? The special rule.
Multiply. If we divide or multiply a number by a negative, we switch it.
That's right. You have to do that still. It still applies.
I'm just wondering because
Don't worry about it yet. So now we need to graph. And now we need a negative 4 and a 5. I got to make sure I fit that in. Negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. And so now we need to graph. We'll put a circle on the negative 4, and it's going to remain open. A circle on the 5, that's going to remain open. But where do we shade? Do we shade in between, or do we shade opposite ends? In between or opposite ends, Laurel? In between? Yeah, the x is in between, so we shade in between. Very nicely done. Any comments, questions, or concerns on how we did this process of solving a compound inequality and graphing? So you've seen one example, and I have very high expectations for what you got out of it. So checkpoint number 1, you got 2 questions. 2 questions, you need to solve both and graph both. 2 questions, you got 4 minutes. She asked me to start. All right, let's get some people involved. A lot of quiet students in the room today. Maybe it's a little intimidating, but it's okay. You give it a shot. So we're on part A only. Part A only. We got number 2, number 7, and number 16. Number 2, 7, and 16. Just tell me your solution to part A. Number 2.
2 is less than or equal to x, and x is less than or equal to 6.
Okay. And number 7?
2 is
Okay, sounded the same. We're not really reading it correctly, but that's okay. You'll learn. And number 16, where's number 16? That's you. Yeah, now it's you.
Negative 3 is less than or equal to n x. I mean, all numbers greater than or equal to negative 3 and less than 2.
Okay, so that was read pretty closer, a lot closer, but the correct solution is x is greater than or equal to 2 and less than or equal to 6.
Oh, wait, no. I read B by accident.
Well, don't do that. That's okay, honest mistake. So when it's a compound inequality with the x in the middle, you start reading from x. So the first two people who volunteered said 2 is less than or equal to x, and x is less than, no, that's not how you read it. You say x is greater than or equal to 2 and less than or equal to 6. And that's what the graph looks like. All right, and part B, let's see what you got. We got number 5, number 15, and number 18. Number 5, what'd you get?
N is less than or equal to -3, and n is greater, less than 2.
Okay, number 15.
N is greater than or equal to -3 and less than 2.
Okay, and number 18.
N is greater or equal to -3 and less than 2.
Okay, so the correct solution is n is greater than or equal to -3 and less than 2. I think that's what they said. Very good, and here's what the graph looks like. Give me a thumbs up if you got both of them correct. Whole team over there, most of the team, whole team here, whole team here. Very nice. Put your thumbs down. Excellent. That was a lot of people. Any comments or questions? So let's now look at what a compound inequality with the word or looks like and how we solve it and graph it. So we have the compound inequality, 3x plus 1 is less than or equal to -2, or 7x minus 3 is greater than or equal to 18. That is one whole inequality. It's a compound inequality. Now, to solve an and inequality, you needed to take your skills and just modify it a tiny bit. In this case, we don't have to modify anything. Even though that's one big compound inequality, you actually solve them separately and put the word or in between them. So we will solve this. Excuse me. We will solve this. We'll take the word or, solve this, and make sure that the smaller number is on the left, and that is it. So, that's no big deal. You already know how to do that. What's the first step in solving this one? First step in solving the inequality on the left. Marcus?
Subtract 1 from both sides.
Good. In this case, it's from both sides. Very good. What's the first step in solving this one? Yudesh? Add 3 to both sides. But let's just go ahead and finish this one first. This cancels out, and we get 3x is less than or equal to -3. Divide both sides by 3. That cancels, and we get x is less than or equal to -1. Bring down the word or. Or, now solve this. Yudesh already got us started. Add 3 to both sides. That cancels. We're left with the 7x greater than or equal to 21. Bless you. Divide both sides by 7. That cancels out, and we get x is greater than or equal to 3. make sure that the smaller number is on the left so that that whole expression makes sense. It is, so we solved it. Anyone have any comments or questions on how we solved it? So let's go ahead and do the graph. Put a -1 here. 0, 1, 2, 3, 4. And graph. Looks like a closed circle on the -1. And a closed circle on the 3. And what about shading? Where do we shade? In between or opposite ends? In between, opposite ends. Amani? What do you think, Cheyenne? Yeah, we're going to shade opposite ends. There. There, and make sure you put an arrow on the ends to indicate that it goes on and on forever. Anyone have any comments, questions, or concerns about how we solve the OR inequality? All right, checkpoint number 2. You have 2 questions. You're going to have 4 minutes. I made a mistake. This is supposed to say solve, and it's supposed to say graph the solution as well. So solve this one, graph it, then solve this one and graph it as well. You have 2 questions. You got 4 minutes, although I think at this point you should need even less time than that. Good luck. Go. see how we did with the ors. We got number 16, number 20, and number 22. So just read me your solution to part A, number 16. Where are you? That's you again.
X is less than 1 or X is greater than 6.
Okay, where's number 20? Go ahead. So you agree here. Where's number 22? Go. So everybody seems to agree that it's x is less than 1 or x is greater than 6. Here's what the graph looks like. I made a mistake when I copied the graph. I somehow cut off the numbers, so I apologize for that. That's the 1, and that's a 6, and you should have opposite ends shaded. Okay, what about part B? Part B, you got number 13, 16, and 23. Where's number 13? Where's number 16? That's you again. Number 23. Good. What'd you get?
X is less than or equal to 5 or X is greater than 7.
Okay.
X is less than or equal to 5 or X is greater than 7.
Sounds like you agree with Chanel. Number 23.
X is less than or equal to 5 or X is greater than 7.
And that is correct. And here's what the graph looks like. And it's a little hard to tell because my projector's not projecting color correctly, but these are shaded opposite ends. Give me a thumbs up if you got both questions correct. A lot of people. Wow, very impressive. Put your thumbs down. Are there any comments or questions on either of these? Kevin?
What if you forget to put the ors?
Then I will mark it wrong. That's part of the statement. It cannot be forgotten. That's a very good question. Must put the or. Because remember, even though we're treating this sort of separately from this, it's really one large expression. One large inequality. So all of this is really together. Okay, but a very good question. All right, I'm going to put up example 3. You don't need to copy anything. It's a very simple idea that you just need to make sure you're aware of. So you are also in your homework going to be asked to look at a graph and write an inequality from it. And so I have a very simple method, and you could probably do it without me helping you at all. But here's the graph. And we need to write an inequality. Which type is it going to be? Is this one going to be an or an and? Marcus? It's going to be an or. So watch what you can do. See the dots? See the number? Start by writing down those numbers. -8, 0. Now, where is the shading? That's where the x goes, right? So the x is going to go over here, and this x is going to go over here. Now put in the symbol. The x's are going to be less than or equal to -8. These x's are going to be greater than 0. And Marcus already told us that that's going to be an or. Now this one we just want to switch around so that it says x is greater than 0, but basically we're done. The and is equally easy. Start with the numbers. -2, 5. Where does the x go? In the middle. This tells you the symbol. That tells you the symbol. Not hard. So that's going in reverse. So this was the first time we started at the graph and went to the inequality. Anyone have any quick questions about that? Good. You guys did a great job with compound inequalities. So you're going to reinforce it with your homework. Draw a line across your paper. We're done with today's lesson, and now we go to the homework. On page 101, you're going to do numbers 1 through 12, and on page 102, you're going to do numbers 1 through 4. And you're going to have your chapter 2 test next week. 2-6, 2-7 will be on Friday review, so it will be next, I think next Wednesday.